Good evening all. I think all are very safe at your own home. So हमने पिछली क्लास में पढ़ा था कूलम्ब्स लॉ, उसका डेफिनेशन एंड इट्स फॉर्मूला, और हमने उस वक्त भी बोला था कि इन नेक्स्ट क्लास वी विल लर्न अबाउट कूलम्ब्स लॉ इन द वेक्टर फॉर्म. So today we learn about the Coulomb's law in the vector form. It's very important, and how this Coulomb's law in the vector form, it supports the Newton's third law also. Okay, so let us see. So in that you have to recall some of the vector notations and some vector formulas, okay, which you learn in your previous class, that is class 11 science. Okay, now see Coulomb's law in the vector form. Okay, so for this we know that the Coulomb's law is what? It is about the force experienced by the two charges when they are kept at some distance. Okay, some distance, small distance apart. So it will experience the force. You know the like force, like charges that will give the repulsion. Okay, and the unlike charges that will give you the attractive force. Now for this, let us consider the two charges, that is Q1 and Q2. That this charge is Q1, okay, and another charge which is kept at some distance, let this be Q2. This is your Q2, okay. Let this position is A, this position is B. So the other two charges Q1 and Q2, okay, which are kept at some distance. Suppose there is a distance between them. There is a gap between them. There is a gap between these two charges Q1 and Q2. Now here you will see. With respect to whom, right? Suppose we are talking about the force on Q1 due to Q2. So we write it like this, F12. This is what? This is the force on Q1 due to Q2. It will be like this, okay. Now force on Q2 due to Q1, it will be like this, that is F21. Because they experience the repulsion force. They experience the repulsive force. Okay. And the position vector. We are talking about the position vector. That means what? The position of Q1 with respect to Q2. Okay. This is your like this. Position of Q1 with respect to Q2. And position of Q2 with respect to Q1. Okay, so this direction will give you the position of Q2 with respect to Q1. So this will be your R21. Okay, R21. And this will give you your R12. This arrow shows what? The position of Q2 with respect to Q1. Okay, and this will give you what? The position of Q1 with respect to Q2. This one. Position of Q1 with respect to Q2. This position of Q2 with respect to Q1. Okay. Or you can say the position of Q2 with respect to Q1. This means. And this means you can say the position of Q1 with respect to Q2. Okay. Now, we know that this is a force. Okay, number one, that is force experience. Force experience by Q1, okay, with respect to Q2, with respect to Q2. So that is F12, you know, this is your F12. F12 equals to your K, Q1, Q2 upon R12, okay, R12 square and R12 position vector. This is your R12, this is position vector. It means the force on one, this means Q1 due to Q2. So the direction will be this, which you will have, will take this one, that is R12. Okay. Now we know that position of Q2 with respect to Q1 or position of Q1 with respect to this one Q2, they are same, but they are opposite in direction. They are opposite in direction. So for that, what to do? We know that R12 can be rewrite as R12 can be rewrite as minus R21. You can also write like this. Okay, because they are position vector, but they are acting in opposite direction, right? So we will take now. Suppose now this is one is what is the force experienced by Q1 with respect to the Q2. Now the second case we will take, that is what segregation क्या लेंगे? Force experience by Q2 with respect to Q1, or you can say the force experienced by Q2 by Q1. Okay, by Q1. So in this case we have what we will have what F21. Okay, F21 equals to KQ1 Q2 upon R21, okay, vector square, and R21 position vector. But you see here we will see that R12 equals to what? It is R21. Okay, R12 equals to R21. So we can also write it like this, that is F21, okay, equals to, it is KQ1 Q2, KQ1 Q2. This can be also written as R21, okay, R21, and this is your R21 whole cube, sorry, modulus whole cube. So you can also write like this. Okay, now this can also be rewritten as like this, you see. Okay, so we can rewrite it like this, that is what F21 equals to KQ1 Q2 upon modulus of R21 whole cube into that. You can also write it like this. This step there is no need to write. We can also write from here, that is R21 square, okay, and this can be write by using this one. We will use here, that will be, it will be your R12. You can also write like this, but it is a minus like this, R12. Okay, it is like this. So R21 को minus R12 लिख सकते हैं, और R21 को 21 को minus R12 लिख सकते हैं, R21 को minus R12 भी लिख सकते हैं. We can also write it like this, that is R21, okay, 21 is equals to minus R12. You can also write like this. So we use this here. Okay, see. So it will be what? It will be, or you can also rewrite like this. इसको हम दोबारा लिख सकते हैं because it is a square. Okay, so we can also write like this: KQ1 Q2 upon R12 square. This is your minus R12. Okay, so this we can also write like this. It is minus K Q1 Q2 upon R12 square, and this is R12. Okay, now you see this is equal to what? This is equals to, this is equal to what? It is equals to F12, that is equals to minus F12. Okay, so from this we conclude what? That is F21 is equals to minus F12. This is your Newton's third law, you know. Newton's third law says what? Equal and opposite force. Okay, when you push any object, when you pull any object, then there will be always equal and opposite force. Okay, that will be expressed by the both the bodies. So here also these two charges, they are expressed the equal and opposite force. Okay, is this charge Q1 on Q2 will be in this direction, and the force on Q1 due to Q2 will be in this direction. Right, that means both the forces are in opposite direction, but their magnitude is same. Direction is in, minus sign shows what? Negative sign shows what? That the direction of the forces are in opposite direction because they repel each other, right? So the force experienced by these two charges will be in opposite direction, but the magnitude it will be same. Okay, as per the Coulomb's law. So this is your vector form of Coulomb's law. Vector form of Coulomb's law. Okay, so for this section it is now okay, and now we will learn in our next class. We will learn about the force experienced by the multiple charges. Okay, when they are kept at some position, in that we will also take the use of the position vector with some reference point. So, and after that we will also learn about the superposition principle by the multiple charges on one particular charge due to different charges which is kept in a particular space. Okay, thank you so much.